All right. Hello, everyone. My name is Jerry. I am a UBC volunteer. Today, we are going to talk about the chapter sequences and series. So here are all the topics that's covered in this chapter. Okay, I will start with the first topic. So the first one is a simple number patterns. So what is a pattern? A pattern is just a way the number changes. For example, you can pause the video for 5 minutes and answer the following 4 questions. All right, great. Let's look at each question together. The first two are pretty easy. So the first one, you can see it starts with 50 and it minus 2 in each next term. So it follows a certain pattern. And the second one is that the first number is 10, which is 10 to the power 1. A second number is 100, which is 10 to the power 2. And also the third number is 10 to the power 3. So these patterns are not hard to find. So the first pattern is that the sequence starts with 50, and each number is the previous one minus 2. And the second pattern is that the ith number in the sequence is just 10 to the power I. Okay, the third sequence, it starts with 4, and it adds 3 to the next term. So the pattern is that it starts with 4, and each number is previous one plus 3. Or you can also say that the ith number in the sequence is just 3i plus 1. Okay, the next question is a little bit hard. So we have 4 numbers, 1, 4, 16, and 64. They seem to be related to 2, right? And they are. So the 1 is just 2 to the power 0, 4 is 2 to the power 2, 16 is 2 to the power 4, and 64 is 2 to the power 6. So that means if we can find the pattern in the sequence 0, 2, 4, 6, then we can just get the pattern of the original sequence, right? So what is 0, 2, 4, 6? It is 2 multiply 0, 2 multiply 1, 2 multiply 2, and 2 multiply 3. And further, it is 2 multiply 1 minus 1, 2 multiply 2 minus 1, 2 multiply 3 minus 1, 2 multiply 4 minus 1. And that means the pattern of this of 0, 2, 4, 6 is that the nth number is just 2 multiply n minus 1. So if you put that pattern back into the original sequence, you can get the pattern of the original sequence, then the nth number is just 2 to the power 2 multiply n minus 1. So the fifth number is 256, which is equal to 2 to the power 2 multiply 4. And also you can get the sixth number and seventh number. Okay, next let's talk about sequence. So the sequence is very easy. It's just a set of number that you will get after following a pattern. For example, those are 3 sequences that we get from the previous exercise. Yes. Next one is a very important concept, which is arithmetic sequence. So an arithmetic sequence is a sequence of numbers such that the difference from any succeeding term to its preceding term remains constant, and this constant is called common difference. For example, if you have 1, 3, 5, 7, 9, then this is an arithmetic sequence with common difference of 2. But if you have a 9, 7, 5, 3, 1, this is also a arithmetic sequence, but with common difference of minus 2. Because remember, when you calculate the common difference, it's always the second term minus the first term. So for the sequence 9, 7, 5, 3, 1, the common difference is equal to, for example, second term minus the first term, which is 7 minus 9, which is equal to minus 2. Next is geometric sequence. So it's a sequence of non-zero numbers, and each term is like it's found by multiplying like the previous one by a fixed non-zero number. And this fixed number is called common ratio. So for example, if you have a sequence of 1, 2, 4, 8, 16, then this is a common ratio, this is a geometric sequence with common ratio of 2. Because if you divide the second term by the first term, like you divide 2 by 1, then you get 2. Okay, next, please pause the video for 5 minutes and answer the 3 questions. So first, you should classify each sequence into arithmetic sequence or geometric sequence. Then if it's arithmetic, you find the common difference, and if it's geometric, you find the common ratio. And there is one sequence that's both arithmetic and geometric. So you need to find both the common ratio and the common difference. Okay, let's look at the first one. So the first one is an arithmetic sequence because if you minus the first term from the second term, which is you like minus 1/2, minus 1/2 is equal to minus 1, and this is equal to the result of you minus the second term from the third term, and also the result of you minus the third term from the fourth term. Okay. And the next one is a geometric sequence with common ratio of minus 1/2. So because if you divide the succeeding term by the preceding term, you get the same number of minus 1/2. It's pretty easy. And the last one, it is both a arithmetic sequence and also geometric sequence. So for arithmetic sequence, it has a common difference with 0 because all the numbers are 2. For geometric sequence, it has a common ratio of 1. Yeah, because odd number 2, so if you divide any number by its previous number, the answer is 1. Next, let's talk about progression. So the difference between sequence and progression is that they are both a sequence of numbers with follow certain patterns. But a progression is a specific kind of sequence, given that we can find a formula to calculate the nth term in the progression. And both our arithmetic and geometric sequences, they have specific formulas. So an arithmetic sequence is also arithmetic progression, and same for the geometric sequence and geometric progression. So for arithmetic progression, let's assume that the first term in the progression is a1, and the common difference is d. Then we can calculate the nth term of the progression by this formula. An is equal to a1 plus n minus 1 multiplied d. And there is a formula deformation that is if we know the mth term instead of the first term in the progression and we want to know nth term, then we have a formula that an is just equal to am plus n minus m multiplied d. Okay, you need to memorize these two formulas in order to solve like the questions. Okay, the second one is geometric progression. So if the first term is a1 and the common ratio is q, and we want to know the nth term of the geometric progression, we have a formula that is an is equal to a1 multiply q to the power n minus 1. And we also have a formula deformation. So if we know the mth term and we want to know the nth term, we can use a formula that an is just equal to am multiply q to the power n minus m. Okay, next please pause the video for 5 minutes and try to solve the following question. Sorry. So still, you need to classify each of the sequence into geometric or arithmetic and find the common difference, common ratio, write down the formula, then use that formula to calculate the next term in the sequence. Please pause the video. Great. So let's look at the first question. So let's first check if it's arithmetic. We minus the first term from the second term and we get -1. But if we minus the second term from the third term, we get -1/3. So it's not equal to -1. So this is not arithmetic. Then let's check if it is geometric. And it is. So if we divide the second term by the first term, we get 1/3, which is the same result if you divide the third term by the second term, or if you divide the fourth term by the third term. So this is a geometric sequence, and we know that the common ratio is Q is equal to 1/3, and the first term A1 is equal to 3/2. So we can write down the formula. Okay, sorry. Then we need to calculate the next term. So we have 4 terms in this question. So the next term has n equal to 5. So we just plug n equal to 5 back to the formula, and we get A5 is equal to 1/54. Okay, next question, you just need to follow similar steps. So I just list all of the steps here. And it is an arithmetic progression. And we get the common difference is equal to -1/2. And the first term is 5/2. So we can calculate the formula and use the formula to calculate the next term with n equal to 6. And finally, we get A6 is equal to 0. Okay, the last question, it is both arithmetic and geometric. For arithmetic, it has a common difference of 0. And for geometric, it has a common ratio of 1. Yeah, it's pretty easy. Okay, then I summarize some general steps to find the progression formula. So the first step is that you need to determine if it's arithmetic or geometric by calculating its common difference or common ratio. And note that it's always the second term minus or divide the first term. So if you have a sequence number like 1, 0, -1, -2, -3, the common difference is -1, which is equal to 0 minus 1. Okay, it is not 1. Yeah. So the second step is that you find the first term A1. After you find the first term A1 and you find common difference or common ratio, you can just write down the formula. Okay, next let's look at the sum of arithmetic progression. So if you have an arithmetic progression with the following formula, an is equal to a1 plus n minus 1 multiplied d, then we have two formulas to calculate the sum of the other terms in the progression. The first one is that when the last term, which is an, is given, then you can just calculate Sn is equal to n/2, multiply a1 plus an. But when the last term is not given, you can also calculate the sum by Sn is equal to n/2, multiply 2a1 plus n minus 1 multiply d. You need to memorize these formulas in order to solve questions. Okay, this is optional, but I think you should look at it in order to further understand how do we get these formulas. So suppose we have an arithmetic progression a1 up to an, and we can write the sum in this way, which is Sn is equal to a1 plus a2 all the way up to an minus 2, a minus 1, and an. But if you write an first and you write a1 at the end, you can also write it in this way. So Sn is equal to an plus an minus 1 up to a3 plus a2 plus a1. Then if you add these two equations together, you can get 2Sn is equal to n multiply 2a1 plus n minus 1 multiply d. This is because if you add the first terms of the two equations, like if you add a1 plus an, then a1 is just a1, but an you can calculate it using the standard formula. So an is just a1 plus n minus 1 multiply d. Finally, you get a1 plus an is equal to 2a1 plus n minus 1 multiply d. And same for the second terms. So if you add a2 to an minus 1, so a2 is a1 plus d. An minus 1 is a1 plus n minus 2 multiply d. So you get the same result as the first equation, which is 2a1 plus n minus 1 multiply d. And same for the third term. So you can see that if you add the first terms of both of the equations and the second term and the third term, and so on, you get the same result, which is 2a1 plus n minus 1 multiply d. And you have n combinations. So if you add these two expressions, the final answer you will get is 2Sn is equal to n multiply 2a1 plus n minus 1 multiply d. But you want to know the expression for Sn, not 2Sn. So you divide both sides of the equation by 2, and you get Sn is equal to n over 2 multiply 2a1 plus n minus 1 multiply d. And this is equivalent to n over 2 multiply a1 plus an. Next, let's talk about the sum of geometric progression. So if you have a geometric progression with a standard formula an is equal to a1 multiply r to the power n minus 1, r here is the same as q before, which is a common ratio. Then the sum of this progression is a little bit complicated, so but you need to memorize it. It is a1 multiply 1 minus r to the power n over 1 minus r. The proof of this summation formula is not that easy to explain here, so I didn't include it here. Yeah, you just need to, I think you just need to remember this formula, that's enough. Okay, please pause the video for 10 minutes and try to solve the following two questions. All right, let's look at the first one. So the first one, we know that a2, which is the second term, is equal to 2, and the fifth term is equal to 1 over 4. So in this case, we need to use the formula deformation, which is if we know the mth term and we want to know the nth term, we have a formula then to calculate it, which is an is equal to am multiply q to the power n minus m. So we know a5 and we know a2. So in this case, we are not using the formula to calculate an, but we are using the formula to calculate q. So we plug a5 and a2 back into the equation, we get a5 is equal to a2 multiply q to the power 3. Then you can solve for q. And then we can calculate a1. So we can use a2 to calculate, or we can use a5, but I use a2 because it's easier. So a2, we know that is equal to 2, and it is also equal to a1 multiply q to the power 2 minus 1. Then you can calculate a1 is equal to 4. Then you know a1 equal to 4, and you know q is equal to 1 over 2. You can use the formula to calculate the sum of the first 10 terms. And you get the answer of 1023 over 128. The next question, we have a sequence of numbers. So the first thing we need to do is to determine if it's arithmetic or geometric. So this is similar to the exercise we did before, so I didn't include the details here. So you just need to use the find progression formula steps in the previous slides to solve the question. So finally, you can see that this is an arithmetic progression with common difference of -3/4, and the first term is 4/5. And we don't know the 10th term, so we can use the second formula, I think, of the summation of arithmetic progression, which is Sn is equal to n/2 multiply 2a1 plus n-1 multiply d. And you get the answer of -19. You can also calculate the 10th term using the formula for an, and you get the 10th term is equal to -23/5. Then you can use the first formula for calculating the summation, and you get the same answer. Okay, so here I summarize how to find the sum of progressions. First, you need to determine if it's arithmetic or geometric. Use the steps that we discussed before. Then you look at all the information that's given in the question. And if it's arithmetic, you need to try to find A1 and D. And there are two formulas that you can use to find A1 and D. One is the original formula, and another is the formula deformation. And same for geometric, you need to find A1 and Q. And also you can use the original formula and the formula deformation to do that. Then after you find all the factors, you can plug them into the sum formulas to find the sum, to find the summation. Yes. So let's look at a sample question from KCSE. This is sample question from a 2022 math paper 2. So an investor took a loan from bank that charged interest. The loan and the interest accrued were repaid in monthly installments. The investor repaid 1,500 in the first month, and in each subsequent month, the installments were reducing by 50 until the loan was fully repaid. So determine the maximum amount that might be paid for that loan. And the challenge question is to determine the third maximum amount that might be paid for that loan. So first we can see that this is an arithmetic sequence, right? In first month you pay 1,500, then your amount reduces by 50. So in second month you pay 1,450, and in third month you pay 1,400. So you can see this is an arithmetic progression with common difference of -50. And first term is 1,500, and the last term is 50. So you can calculate the summation using both formulas. Oh yeah, but before that we need to know n, right? Because you need n, whether you use the first formula to calculate summation or you use the second formula, you still need n. So we need to calculate n. And we can use the standard formula, the original formula of an to calculate n. So you know an, you know a1, and you also know d. Then the only unknown in this equation is n, so you can calculate it. Then we get n is equal to 30. We can then use the sum formula to calculate the summation, which is equal to the maximum amount that might be paid for the loan. And the summation is 23,250. The challenge question is asking the third maximum amount. So what does this mean? So if the question is asking the maximum, that means you pay all the sequence of monies until you don't have any money remaining to pay. That is, your money reduces to 0. and that amount equal to the loan, to the amount of the loan. But if the question is asking the second maximum, that means you don't need to pay the last number, which is 50. And then you pay off all the loan. Similarly, if the question is asking the third maximum, that means you don't need to pay the $150 and you can pay off the whole loan. So the third maximum is just, you just need to calculate the sum of the following terms. You still start with 1,500 and you minus 50 in each next term, but your last term is 150. Okay, so you determine A1 is equal to 1,500, AN is equal to 150, and you get D is equal to minus 50, and use similar steps to get N is equal to 28. Then you can calculate the summation. Okay, let's go over everything we have learned in this chapter. So first we learned the number patterns, and pattern is just the way that number changes. So you can see some example. Then we learn sequence. Sequence is just a set of all the numbers that you will get after following a certain pattern. Then we learn two of the most important concepts in this course. I think they are arithmetic sequence and geometric sequence. Arithmetic sequence is also arithmetic progression, and geometric sequence is also geometric progression. They are equivalent. And you need to memorize the general formulas for arithmetic and geometric on the right. Then we learn how to find the formula that we list here. Please look at it. After that, we also learned the sum of the progressions, and there are two formulas for arithmetic and only one formula for geometric. And I think that's it. Thank you for everyone coming to this session. This is our first session. I hope you enjoy it.